This is the notes for the 1.7 notes from Honors Geometry using angle definitions and angle addition postulate. We did a little bit with angles already yesterday, or on Friday, so let's go ahead and pick up with what this angle addition postulate is as well. So please make sure you're following along, writing this all out as we're writing it together, and then you'll get some time to try some of those out, the examples, and we'll have this video pause, and then after you've gotten some time to try it out, we'll make sure to, I'll have this up, unpause it so that you can watch the explanations as well. Anything that's unclear from this, I will explain in more detail tomorrow. All right, so the angle addition postulate is just like the segment addition postulate, but now we're applying it to angles. Okay, so it says here to draw a picture where P is on the interior of angle RST. So on Friday we talked about how to draw an angle. Here is my angle. We need 3 points, and these are rays, 2 rays put together, so those can go on. And the point here could be RST. Okay, and so we want to put point P in the interior. That means somewhere inside here, you want to just pick a point and label it P. Now I'll connect it just so that you can see kind of what this looks like, and it could be another ray, because it created another set of angles now. Instead of just having the one, now I have them kind of, I have 2 angles now here. Now they're not cut in half necessarily. It did not say that they are congruent or that PS is bisecting. That we talked about angle bisectors on Friday. We don't know any of that. These two don't necessarily need to be the same, but now it's created 2 of these angles, plus we have the larger one that makes up those 2 smaller angles. So if P is on the interior of angle RST, then we can go on to say that the measure of angle RSP, that's this first one, RSP, you could have also called it PSR. Remember the order, I can write it this way or the other, and it's still referring to the exact same angle. And then I would add to that either PST, measure of angle PST, remember you could say TSP, same thing, and that should equal the large angle here, measure of angle RST. This is the angle addition postulate, just similar to what the segment addition postulate was, but you're seeing it with angle measures. Don't forget the little m's in front of the angles, because we're talking about measurements for those, saying that this plus this equals that. Whenever you have an equal sign, you cannot just deal with congruence then, you're dealing with equals, and that's why we have to put the little m's. Same with how we did the segment addition postulate. We said that the 2 segments added together were equal to the 3rd segment. We were talking about lengths of those segments, not just the segments themselves. Okay, so that's a little bit about the angle addition postulate, and just want to clarify though that the angles do not have to be congruent. They can be, but then we're looking at more so like a bisector like we talked about on Friday. So the angles do not have to be congruent. Remember, that's the symbol for congruence. And specifically then that segment or ray PS is not necessarily an angle bisector. It can be, but you can't assume that it is if that information is not provided to you. Okay, so this is just kind of some notes to keep in mind as we now try to try some examples or try to understand this in some more detail. Make it a little clear here. Okay, so use the image to answer the following questions. So we have this image here. You want to list 3 things about this image. Now I could list way more than 3 things. I'm going to go ahead and point out a few things, and then we're going to walk through these different statements to see if those statements are true or not, to really understand this picture in more detail. Now you could label or list other things that I don't have. I'm going to go ahead and just pick 3 of them. So the first thing I see is really clearly that I have some congruent angles. You can either say that angle 1 is congruent to angle 3, or that the measure of angle 1 equals the measure of angle 3. We know both those pieces of info right from this diagram. And then we're going to go on to see what else we can write. What about using the angle addition postulate, what we just saw? We could say that two angles together, added together, will equal a third angle. So we could say measure of angle 1 plus the measure of angle 2. I want to talk about these two together. I want to say then that it makes up this larger angle, PTR. Measure of angle PTR. Or you could say RTP. Okay, do another one, because again we need to list three things, so we'll just do another set here. I could say angle 2, measure of angle 2 plus the measure of angle 3 is equal to, again, the larger angle that makes up those, QTS. Yours could look different. Again, these are just the ones that I chose. You could pick ones that are different from this. Okay, on to number 2. Now we're going to circle all the ones that are true, or that actually says which of the following statements are true. Select all that apply. So there can be more than one right answer. Let's look at the first one. Measure of angle 1 plus a measure of angle 2. Now instead of saying measure of angle 3 though, it said measure of angle 1 again. And it goes on to say that that is equal to PTS, this whole angle that you see in this diagram. Well, since we know that measure of angle 3 and 1 are the same, they are equal to each other, we are actually able to say that this statement is true. Although the way that you're most likely going to see it would be with a 3 here. That would be kind of like the angle addition postulate. This we're going to talk more in the next unit too about substitution, or not next unit, but coming up we'll talk more about different postulates and theorems. That's essentially what we're doing here. We're just saying that since 3 and 1 are the same, we can replace that 3 with it. But the next one says that all 3 of those angles are equal. That we don't know is true, because we don't know what PTS is, and same with all the other, I'm sorry about that, we don't know about all the other angles on there. All right, so moving on to letter C, it says here angle 1 is equal to angle 3. That we can see is true, but here's the tricky part. They've left off the little m's. This is the best way to write the answer. I can't write it the way they've written it here, or you could say angle 1 is congruent to angle 3, what I wrote above. So C is actually not correct because the notation is incorrect. So kind of tricky on that one. Look at it carefully. It wasn't the correct notation. And then finally, letter D says PTR, measure of angle PTR, and subtracting out angle 2 from that, you're going to be left with just angle 1. And that would definitely be true, because if you have this whole big angle, PTR, and you're just taking away 2, that's exactly what you're left over with. All right, on to number 3. Here's another example using the same kind of postulate. We're just kind of applying the same idea, looking at the diagram. It says if angle PTS, is this entire angle here, is 100 degrees, and measure of angle 1 is 30 degrees. I'm going to go ahead and label it there. Remember that 3, measure of angle 3, is also 30 degrees. So if I have 30 and 30, that would be 60 degrees. And I want to subtract 100 from that, so I can figure out the measure of angle 2. So 100 minus 60 would be 40, so the measure of angle 2 would be 40 degrees. Now we're going to go ahead and pause the video because we've gone through some of these examples. Now, just like you see that little symbol that tells us that you can try this out with a partner, you can also work on it on your own, but this is time for you to try it. If you do decide to move around and work with somebody else, you could take about 10 to 15 minutes to try out numbers 1 on this page, and then the next page 2 and 3 and 4. So, and I'll have the sub kind of look at the time and let you know, or I'll make sure that they can play or press pause again to kind of restart the explanation for the bottom part for the rest of it, so that you hear it before you leave today. All right, so go ahead and get started, and I'll have the sub please pause the video right here. Okay, so hopefully you've gotten some time to work through the 4 examples. Even if you did not finish and you want to work through that some more, you can always look at the answer key that's posted in Canvas, and I can go through this in some more detail tomorrow. So our first question here, if measure of angle ACS is 115 degrees, what additional piece of information could you be given in order to find the measure of SCR? And if we could, can we even find a second option for that? So I'll try to write out two options that you could take. So if you knew, or if you know, the measure of angle ACR, that's the other portion of this whole big angle, then we can use the angle addition postulate. To find the measure of angle SCR. Okay, so that's one thing we could do. The next thing would be if we knew anything about if CR was an angle bisector. So, or if you knew if ray CR was an angle bisector. And so if that was the case, then you could cut 115 degrees in half. Right? Because an angle bisector would give you equal halves here. If we knew that this was being bisected, only then would we know that we could take 115 and cut it in half. So lots of information missing here. With only knowing ACS is 115, we really can't go on to do anything at all. Okay, so let's try a couple more. Number 2 has us finding the missing angles. And so we have to think about everything we learned on Friday with the types of angles, like straight angles, right angles, and kind of work through finding those missing angles. Now today we're going to see a little introduction to something called a vertical angle, which you may not have been able to do if you struggled with some part of this. It's because it'll be easier tomorrow when we learn about this thing called a vertical angle. And vertical angles are congruent or equal to each other. And so that means that they're like across from each other vertically. So example of letter B here is across from this 160. So that's one way that you could figure out that B is 160 degrees. But we'll go through it another way too in case obviously you didn't know this piece beforehand. So let's look at letter A though. A and 160 are sitting on a straight line right here. So this is a straight angle. And that's what we talked about on Friday. A straight angle is always 180 degrees. So if we have 160 here, then we know that A has to be 20 degrees. Because together they have to add up to 180. So then same thing, you could use the same concept if you didn't know about vertical angles. You know again that the A that you just figured out, this 20, and B have to also be on a straight line, have to be 180. So that's how we get 180 minus 20 to get 160 here. Okay, so we got everything on this right side. Let's come over to the left and try to figure out C and D. Now this has to do with right angles, right, or 90-degree angles. Remember, the symbol represents 90 degrees. And again, you can see that the vertical ones are equal to each other, across from each other. So to find letter C, first of all, you have to do 90 minus 75 because that's what's left over for this right angle. And the reason this has to be a right angle is because, again, you're on a straight line. And if you have 90 degrees, then another 90 will make it 180. So C is 15 degrees. And if we know that this is 15 degrees and 90, again, you could work with the straight line again. D would have to be 75 degrees. Again, the easiest way is we're going to learn more about those things called vertical angles. For right now, if you don't realize that that's what it is, you kind of just have to look at the diagram and see how across it's the exact same. If this is 15 here, and D would have to be 75. Okay, so that's a little bit about those angles. And again, we'll do more with angles tomorrow. Number 3, we have measure of angle XYW, which is this portion here, and we want to find the measure of angle ZYW as well, the bottom part. And so you're only given that XYZ, the whole thing is 72 degrees, so let's set up the angle addition postulate. That's what we're doing on this one. Okay, so we have 3x plus 6, it does not matter which one you write down first, plus 2x minus 9 is equal to 72. And now we're solving for x. Once we have what x is, we'll substitute back in to find both of those angle measures. So we have 5x minus 3 equals 72. Then when you add 3, you would get 5x equals 75. Divide by 5, and you get x equals 15. And once I know what x is, now I can find both those missing angle measures. So let's start with xyw. xyw would be 2 times 15 minus 9, or 30 minus 9, which is 21 degrees. So that is measure of angle xyw. We're halfway done. We're almost done. We just have to find the last part, which if we know that 72 is the whole angle, you could just do 72 minus 21, and we get 51 degrees. So the measure of angle xyw, or whichever way you decide to write it, but I'll write it the same as the original problem, is 51 degrees. Don't forget the degree symbol. Don't forget the label for n, saying it's a measure, and then writing out the 3 letters for the angle. You can't just call it angle y, because we don't know which part would be referring to for angle y. So please make sure you're using 3 letters for that. All right, so that's number 3. We use the angle addition postulate to find both missing angles. Now, if you wanted to actually not do this subtraction, you could have also substituted 15 in here as well, 3 times 15 plus 6, and still gotten 51 degrees. And the last one is definitely the longest one. It's a lot to it, so it's okay if you struggled with this a little bit, and we're going to go through all of this again if there's questions tomorrow. So first of all we have to do is use the angle addition postulate to write out an equation. Actually, I'm sorry, this one is not angle addition postulate. It's actually working with an angle being bisected. So we're saying that this is congruent to this. So we want to then set them equal to each other. So it's x squared minus 3x over 4 equals 5x minus 15 over 4. All right, so that's our setup to start with for part A. To find out how to solve this, I'm going to just rewrite it right down here again so we can start solving this. And so when I see fractions like that, I don't like the 4 in the denominator. I'm going to go ahead and multiply everything by 4. That way I get rid of those fractions. So now we have 4x squared, and then the 4 is gone in the denominator, leaving me with just a 3x. 5x times 4 would be 20x, and then again the 4's will cancel, leaving me with just a 15, negative 15. And move everything to one side. Whenever you have a quadratic or an x squared, we have to subtract the 20x and add the 15. You're moving it all to the other side because you want those to cancel and be 0. And now keep solving. Now you're going to have a choice here in just a minute to use quadratic formula or factor it using any of the methods that you've learned. So here are our choices here. If you choose to factor, there was guess and check, which is definitely the harder of the two because it takes a little bit of practice to figure out what you're guessing and checking with, or that X and table or box method, however you choose to make that, a table or a box. That's one option, or the other option is to use the quadratic formula. Now, in this case, because there's a leading coefficient and number in front of x squared, it's going to make it harder. So that's why I'll go ahead and just do the x box method for my explanation here. If you would like to see the other two options, I can go over that tomorrow as well. So let's just do the x box method. Starting with the first, you multiply the first and the last, so 4 times 15 is 60. The middle number comes on the bottom, so that's negative 23. And then you come up with two numbers here. Negative 20 and negative 3 will multiply to give me 60, but add to give me negative 23. So then you go on to this table or the box, and you start putting in everything inside. You use the two numbers you just figured out, negative 20 and negative 3 with the x, and the rest stays the same, the 4x squared and the 15. And we just start taking GCFs out. The first row would be 4x. And x at the top here, and then a minus 5 because it's got to get to negative 20x, and finally a negative 3 for that bottom row. So we would write this as 4x minus 3 and x minus 5 equals 0. Set them both equal to 0 to get two answers. You do get either a decimal or fraction for this one. It comes out to either 0.75 if you write it as a decimal, or just 3/4 if you left it as a fraction. and we get 5 for the other one. Now, here's the problem. You might look at them and say, well, are they both good because I got no negative answers? No, one of them is still not good, and you don't realize that until you substitute it back in. So until you go back to check it, let's go back into, like, let's say this equation, 5 times 0.75 minus 15/4. If you type that into a calculator or you just calculate it, even if you wrote it as 3/4, it'd probably be easier to see. You actually end up with 0. We can't have, it's not possible to have a negative, or I'm sorry, a 0 for a length, right? It doesn't exist then. So that's why this is called extraneous. We learned a little bit about extraneous in algebra last year, a lot about it actually, and so that is extraneous. So 5 is good, and here's how you can check. For the 5, you can say 5 times 5 minus 15/4. This comes out to 21.25 as a decimal, or you can write it as a fraction if you prefer to do that. But our final answer was to find ABC. We're almost there. We just found DBC. This is the measure of angle DBC. I want to know the whole thing, so I have to double it because they're both 21.25. And so that final answer comes out to 42.5. I'm going to write it right up here. The measure of angle ABC is 42.5 degrees. Okay, and that's finally it. So if there's any part of this that you missed, try to first look on Canvas tonight and see if you can get that information either filled in at least. And then if you wanted to go over any part of this, bring your questions tomorrow. Please make sure you do your 1.7 homework. Now that you've gotten through the lesson, and whatever you don't finish of it, finish for homework tonight, and then bring that tomorrow with you. Just a reminder also that tonight by 11:59 p.m. your summer packet quiz, which is called the Algebra Skills Assessment on Canvas, is due. So please make sure you do that later tonight if you have not yet done it. All right. If you have any questions, I will go over this tomorrow with you.